the service module. So here you see those two major elements, the crew module on top being lowered on top of the service module. And then what we did is, you can see the black, those are thermal protection system tiles. That's what protects the crew cabin as it's re-entering. We spent a couple weeks putting those on, and then we subjected this integrated stack to about 1,200 hours of powered on testing. We turned on the computers and ran every subsystem to make sure everything worked the way it was supposed to. Now, this is the third element that will be flying on Exploration Flight Test 1. This is the launch abort system. We put it together in a different building because this has 3 different solid rocket motors, including the 500,000 pound thrust motor, which pulls the spacecraft away in the event of an emergency. So we build this, since it has these 3 big motors, we keep it in a separate building. And we flew this system in May of 2010 to demonstrate this. This is going to show you what it is like if this abort system has to be used. Before we tested each one of the motors. Try that one again. This is a 500,000 pound motor that fires for 2 seconds. We'll get one time, okay. That motor we hope we never have to use, because if we use that motor, then we've had an accident and we need to pull the crew away. The motor on the right, this is one we'll use every time, because this is what pulls the launch abort system off the spacecraft. It's a relatively small one. It's only 50,000 pounds. It fires for about 5 seconds. And this one's kind of neat. It's an attitude control motor. You can see there's 8 different thrust nozzles around the circumference, and depending on the direction you want to go, you fire certain thrusters. When all those motors were developed and ready to go, the net result was this abort test, which we did in May of 2010. You can say 0 to 600 miles an hour in under 2 seconds. That's what that abort motor does. And then the attitude control motor, you can see those jets firing out the circumference. It flips the stack around, and the reason we do that is because we want the CM to fall out. It just drops out of the LAS. You see the LAS separates, the forward bay cover, a couple of parachutes. These drogue parachutes stabilize the spacecraft, because then you'll see 3 pilots pull out 3 mains, and that's exactly how everything is supposed to work. That was the launch abort system flying by the spacecraft. This was the White Sands Missile Range in New Mexico, May of 2010. This is a picture of the launch vehicle, the United Launch Alliance Delta IV Heavy, that was rolled out to the launch pad about a week ago. Earlier in the week, September 30th, and it now is waiting for the Orion spacecraft. Parachutes. When I started with Orion, I said to myself, boy, parachutes, we've been jumping out of airplanes for 60, 70 years. They've got to be straightforward. It turns out parachutes, unlike many other systems like computers where you can have in a lab and you can sit there and work on them for weeks and months on end, the only way you can test parachutes is to drop simulators out of airplanes. So that's what we do. And this is a video from the Yuma test range. And you can see we pulled the spacecraft out of the back of an Air Force airplane, and we practiced deploying parachutes. And you'll see the same thing. These are 3 pilot chutes, and they pull 3 mains out. The mains, you notice they come out narrow, and then we expand them. That's called reefing. And the reason we do that is when you're flying very fast, you don't want to expose the whole canopy. Otherwise, you would exceed the strength of the parachute. This is another interesting system. The top of the spacecraft is called the forward bay cover. And when we're flying, we have a cover on top of the parachutes. But right before the parachutes have to deploy, we have to get this forward bay cover out of the way. It, again, is a very dynamic event. And this video shows you what testing this is like. This is a facility. This is a Lockheed Martin facility in Denver. So you can see just about every aspect of the system we test and retest before we go test fly. This is a picture of the Mission Control Center in Houston, the same control center that we've used for Gemini and then Apollo Space Shuttle and Space Station. Now will we use to provide Orion flight operations support. And these teams are getting ready, simulating, getting ready for December. And When we land in the water. And the people that pick us up are the U.S. Navy. And this is an exercise that the Navy conducted just last month, practicing recovering the spacecraft. They sent out a couple of Zodiac boats, and then they pull the spacecraft into the back of that big landing ship. That landing ship is used to deploy Marines. And we were very lucky to be able to use it to recover Orion on this test flight. I think that's it. So,
This is the
all
video
right.
that simulates our first crewed mission.
All right, we're going to end with one last video.
T-minus 3 hours and 4. And we're now in the final 5 hours of the countdown. Crew going down the elevator has been used by the astronauts ever since Apollo.
It is great to be in Florida today. The rocket is ready to go fly. The team is ready to go fly.
The new mission is quite a bit different than the shuttle mission. The next mission is to go beyond Earth orbit.
T-minus 2 hours, 38 minutes, 6 seconds, and counting as the crew approaches the launch pad.
Not only for expanded knowledge of the universe, but for the improvements you have contributed to on Earth. Have an excellent mission and Godspeed. Crew Denver is working this time. Flight crew, OTC, close the launch advisor, and initiate OTC close.
T-minus 10, 9, 8, 7, 0, and lift off.
All right, thank you very much. So I guess, what's next? We want to open it up for questions?
Yes.
Mark?
So we have a few minutes for questions. I do have a mic I can take up so you can hear them. If for Rex, you can join Mark up here. And just a reminder to follow us on Twitter and Facebook. We post photos, many from today, so many of you see your pictures on our website. So be sure and stay tuned up through December 4th, and you can watch all the new developments in the spacecraft. Anybody have a question?
Hi, I was asking about the Sierra Nevada option. You said I was one of 3 options to choose from. It seemed like the Sierra Nevada wouldn't need the parachute or the water landing for that sort. Why not choose something for that sort instead of the Orion?
Sure. Well, yeah, it definitely did have its advantages. Each one had advantages and disadvantages, and I wasn't part of the source selection board that made the decision of which ones they picked. But there is like I guess some of the advantages of the capsules are that it doesn't you're not exposing your heat shield when you're on ascent. But the advantage of a capsule like the advantage of a winged vehicle is you can land on the land, and any runway that's long enough to support it. So they looked at all that. They looked at the advantage and disadvantage, and they looked at the cost and schedule and past performance and things like that. So they ended up deciding that the best 2 to go with were SpaceX and Boeing.
Serious. I don't want to ask
Can you ask
Other
Here
questions?
we go. This gentleman has a question right here, so turn it, and you can ask Rex.
You had a question?
Left. What's your favorite letter?
What was that?
What's your favorite letter?
What's my favorite what? Letter? S.
Just one more. Okay, one. No, let me find that. One more, okay. No, let me find that. What's your favorite planet?
What's my favorite planet? There's a lot of good ones, but my favorite planet is Earth. Because that's where all my friends and my family are. Other than that, I like Saturn. Saturn's a really neat planet. Thanks. Other questions? Yes.
So when you're doing the drop tests and things like that,
I want that
is that
to
the actual
wear.
Orion spacecraft, or is that a replica, or what is that?
Yeah. Every one of those tests has some form of Orion, but the only flight article we built to date is the one I showed you that we're building in Florida. Every other one of those is a high fidelity model, and they vary. So for example, when you're doing drop testing and you want to see how the loads, it's very high fidelity from a structural standpoint, but you don't need the computers, you don't need the comm systems. It's what you need. The Orion we drop out of an airplane is very interesting. For that, we want it to be as aerodynamically similar to Orion as we can get. So the shape is very important, but there's a problem because the height of the biggest Air Force plane is only so high, and I don't know if you saw it, but we actually had to squish down the Orion. So it's very high fidelity, except slightly compressed, so we can get it out of the back door and drop it out of that airplane. So they're high fidelity, but each one is high fidelity in the areas that are important for that test.
So my question was for the flight in 2021, how long would it take round trip to go?
Okay. Yeah, the flight in 2021 is, we have something we call the design reference mission. It's what we're designing to today. And right now, that flight will be a lunar orbit mission. So it's planned to be a 14-day mission where we'll have crew on board and it will orbit the Earth and return from the Earth. So that one will be relatively short, but the idea is we'll build up our capability up until the point where we have what it will take to go to an asteroid or to Mars.